I've been instructed this is an entrepreneurial section, that we just start when we would like to and we proceed and we expect that others will follow. This is a great session. We have some great speakers who prepared some great information. I would encourage you to be a bit entrepreneurial as well. As I have looked ahead at the presentations, I think you will want to know who these people are to not only have questions at the end of the session, but later on. So I encourage you to read their backgrounds. We've agreed to proceed quickly. With one little bit of introduction, I'll give my context for this. I like the idea of thinking about with a second eye, we get a third dimension, and we're able to see things spatially. And I like to think that as actuaries, as we get trained, we're able to provide that kind of perspective and give a little richer story behind what may be the chaos of data. I would hope that through this instruction that we're starting to see also that the ability to see how data changes over time and the world changes over time is an aspect that some of you might refer to as using your third eye. But it gives us, again, another dimension, which is where I think the actuaries are looking to add value in a rapidly changing world. So without further introduction, we'll get started. We are targeting to be best in class and end within our allotted hour. So I hope if we do, you can give us all a standing ovation because lunch will be waiting right afterwards. So let's go ahead and get started.
Over the last 2 days or so, I've been having some interesting conversation with people I've been meeting at the conference. And these are the people I've been connected through LinkedIn, but may not know them personally. Coincidentally, there's a pattern to these conversations. And a typical conversation would go like this. Hey, Sumit, you've been doing great stuff. You're doing breaking boundaries. You're doing some unconventional stuff. And then, more often than not, it would end up with, by the way, what exactly do you do? While this is one end of the spectrum, in the other end of the spectrum lies my wife, who has been kind of wondering over a year now at what exactly do I do in one small corner of the house that brings her so much money. And ladies and gentlemen, in today's 10 to 15 minutes of this talk, I'm going to answer the audience regardless of in which part of the spectrum do you lie. With that expectation set, let's jump into the agenda. I would start by defining what an insurtech is, and then move on to talk about what tech of insurtech entails, and then we would see whether insurtech is a buzzword or it's something for real. And then I would go and argue why I think actuaries should be amongst the first hires of insurtech, and then I would go on to talk about what this exciting world brings in forms of challenges that we should be cautious of. And towards the end, I would try and wrap up really quick. So insurtech, in very simple terms, is a combination of two words, insurance and technology. And it was inspired by fintech, which is more known in the wider community. To give you the more technical definition, it is technology innovations designed to squeeze out savings and efficiencies from the current insurance industry model. But to put it very, very loosely, it is a tech company trying to get into an insurance market with the intention to add value to the entire insurance value chain. Now that we have some flavor for what an insurtech means, let's spend some time trying to figure out what the tech of the insurtech entail. And regardless of which part of the globe an insurtech exists, they would typically be using one of these 5 technologies or more of them, or a combination of them. And at this point in time, one want to ask as an actuary, what is that I need to know before I could start advising or consulting an insurtech, for example? Do I need to know the entire technology? Should I be an expert in it? Probably not. Can I not know anything about it and still foray into it? Certainly not. So where does the boundary lie? And I've been thinking about it over a period of time, and I think if we could answer 2 questions, we are probably there. And these 2 important questions are, what are the risks that these technology companies or these technologies are trying to cater to or reduce, and what additional risks that these technologies bring in along with them. To talk about a simple example, let's consider an example of smart home insurance, where you would use Internet of Things mostly, and you would also combine with other technologies. One of the things that it is probably trying to solve is reduce thefts, because they have this mechanism of switching on and switching off lights when you're not at home, making people believe that it's still inside. And in the Western world, where the temperatures really go down sub-zero, there are instances where the pipes in the water in the pipes would become ice, and the pipes would burst, leading to leakages and damages because of it. But a technology like this could turn on heaters when temperature goes really down. But they bring a cyber risk. What happens if someone hacks into your home and plays with the device? What happens if the device malfunctions? And you don't know whether these risks exist unless you understand how these technology works. So I think that's the starting point if you want to foray into insurtechs. So smart home sounds like a cool idea, but then only one of the few use cases, or few problems that insurtechs are trying to solve? Maybe not. If you think of it, or if you look at the facts, insurtechs have been there for about 6 years now, and I understand that you can't treat every bit of it, but the important part of it to realize is the greenish lines are for L&H innovations, and the pinkish lines are for PNC innovations. So if you could see, the amount of money invested in them is roughly same over a period of time. And it turns out that over $10 billion have been invested in these companies. $10 billion is huge. And then at this point in time, one might want to ask that who is putting in this crazy amount of money? People who have a lot of money but do not know how insurance works, or people who have money and have some idea of how insurance works. And it turns out that in last 6 years or so, insurers and reinsurers who understand the business have been investing in insurtech. And so which essentially means that they're not a buzzword. They are here for real. They are really creating impact. And where exactly they are creating impact? Pretty much every part of the insurance value chain. You pick one part of the insurance value chain, and there are dozens of insurtechs doing disruptions there. So at this point in time, let's pause for a second and think about what we have been discussing so far in the last 5 minutes or so. We now know that there are several insurtechs that exist. They exist for real. Billions of dollars have been invested in them. Insurers and reinsurers are investing in them, and they have disrupted pretty much every part of the insurance value chain. The question, I'm sure, must be running in most of your mind is it all happening without us? Were actuaries not really involved? Well, the answer is, in several instances, actuaries were involved. There's a few insurtechs were smart enough to figure out that these are the guys we really need if we want to do something in this world. And to think of it, the fate of any insurtech or the aspiration of any insurtech is to eventually collaborate with an insurer or reinsurer. If you are doing a solution for an insurance company, you just cannot not talk to them. Or if you're doing something like peer-to-peer model, which is more like mutual insurance, you still have to talk to reinsurers. And when I say talk, it essentially is a very vague term. What could it mean? And let me try and explain that with the help of an example. It's from one of my personal experiences when I started on my own and started consulting insurtechs. One of my first clients was from the gaming industry, and he had essentially developed a motion sensing game, which means that in order to play that game, you have to move your hands and legs. So his argument was that if my customers are moving hands and legs while playing the game, they are effectively exercising. And how is that different from insurance company offering premium discounts to people using Fitband in their data? I think it makes sense. And he went on to argue that games are far more addictive than running, so I should get a better deal. I said, why not? So the conversation went on, and he said, can you help me talk to insurers? And I said, okay, that's very interesting assignment and fairly vague requirement as well. So we broke down into how do we approach it. And it turned out that we identified few insurers where we had contact. We identified one of the cancer products of an insurance company, reverse engineered it so that I could kind of explain how their pricing works, and did fair amount of research to establish a correlation between the amount of exercise that you do and the impact it has on claim frequency. And then this guy now finally had a model which explained went to the insurance company and said, look, I have a model which explains how your cancer product works. I know what is the reduction in claim frequency if someone, let's say, exercises for an hour a day. And now I can tell you what should be the new premium look like if your policyholders start using my game. And this is all backed by an actuary. With that, it was a very, very easy sell for him. And this was about a year ago. And since then, he has been collaborating across the globe. He started with UK, and I talk to him every few months, and every time I hear a new story from him. So yes, insurtechs are hiring actuaries. And to maybe pause for a moment and think, what exactly did I do here? I applied the techniques which I've been learning from my insurance and reinsurance days in a different setup. Nothing different, right? Just the setup changed. The skills still remain same. And it's not just because of the technical capabilities that we have. We also have several other attributes that, in my mind, makes us to be the first choice of hires when it comes to setting up insurtechs. There's no doubt about the fact that we understand insurance better than anyone else. If we talk about comparing with any guy working in an insurance company. In our heart of hearts, I think we are problem solvers. And I can tell you that with great degree of confidence because I end up meeting a lot of people who are also on career break, who are actuaries but on career break. And one thing that runs common across is I don't miss going to office. I don't miss earning money. What I miss is solving a real life problem. That's something I think is common across all of us. And what InsurTech is essentially doing is solving a real life business problem. Learning, either by choice or by force, we are forced to learn. We learn throughout our life. The fact that the room is pretty much full, I'm sure most of us are here because we want to learn new things and not because of CPD. Yeah. Communications, I think it's crucial when you talk to someone who doesn't understand insurance. And you're talking to techies, probably understand R and Python and machine learning probably better than anyone else, but probably know nothing about insurance. And here, I think CA3 becomes very, very crucial. And again, from my personal story, when I started clearing exams, I actually cruised through my higher papers. Every time I wrote an exam, I cleared them in the first attempt, unless I hit CA3, which took me about an year. I have no regrets because in the process, it has completely changed how I communicate now, regardless of it public speaking or written communication or a one-on-one conversation. It has completely changed. So I think a good amount of importance is given to communication, and that also kind of sets us apart when we get into InsurTech and helping them. And all of us know that whoever knows us has a great degree of respect for what we do and who we are. And that's because our seniors and probably forefathers have ensured that the profession has a very, very high standard. With all these combined, in my mind, we are best placed to be insure of InsurTech. And picking up from the formidable reputation point, while it helps us a lot because I haven't had any challenge in seeking or getting an appointment from an insurance company or CEO of an insurance company, because I'm an actuary, I have a certain reputation as an actuary, but that also means that there's a good amount of responsibility on us to ensure that the standards are high and probably go to the next level. And even though this is a very exciting world, I think that there are several ethical and professional challenges which I thought it might be a good idea to be cautious of. The first one is that some people who are following technology would know that while blockchain was a very good technology, there's also something which came along with was ICO, which in very simple words mean that generating money from thin air. And that's unregulated market. While there's nothing wrong with an unregulated market as such, but there have been several scams in anything with things related to ICO. So would you want yourself to be associated with a scam? Maybe not. But what do you do about it is something we need to probably think about. Data privacy comes quite naturally. A lot of things is now happening with the use of data, which is probably available in public domain. And in some cases, one could try and use data which they are not allowed to or authorized to use to come up with something to predict probably what risks are. But is that ethical? Maybe not. I can't stress more about appropriate skills because unless you know the technology, there's absolutely no point in even trying to think that you could help InsurTech. You need to know the technology at least to a certain degree of level. And the last one is communication. It's important here because now we are talking to techies. We are probably more trained to talk to insurance, guys who understand insurance, but techies, we have to be all the more careful in how we communicate with them. So yeah, I think in my mind, professional considerations become all the more important in this new exciting world of InsurTech. And what do you do when you face an ethical dilemma or a challenge regarding professionalism? I had this personal challenge a few months ago. I was offered a very interesting and lucrative assignment, if I call. But then there were also, in my mind, challenges. And I had a feeling that this could bring in some bad name to me and the profession, and hence there was some reputational risk. At the same time, I was fairly tempted to take that assignment. So I was on a fix. So what I essentially did was talk to senior members in the community who had far more experience than I have. I also reached out to professional support service of IFOA. And then the interesting bit is the response that I got from the senior members, because I had easy access to them, I could call them over phone. And the response that I got from professional service support had similar way of approaching things. I mean, that's probably the importance of experience that seniors bring in. And you could also, regardless of which society you're associated with, I'm sure there are professional bodies to help you. And the response was following. Essentially, it said, while your concerns are quite genuine, that this assignment could lead to some bit of reputational risk, but you don't have to worry as long as you take care of A, B, and C. So you see, the profession is also willing to support you if you are also willing to take some bit of risk and guard you in some sense. So that was essentially my last slide. It's very, very important to comply when you jump into new areas. Essentially, to summarize, while we now understand that insurtechs are here for real, they have been impacting every part of the insurance value chain, and we as actuaries are best placed to help insurtechs, but at the same time, we should be cautious of professional considerations. If I were to summarize the entire presentation in one line, I think we are definitely best placed to help insurtechs as long as we are willing to take some bit of risk and take some bit of courage to move out of our comfort zone. Thank you. Any questions?
Yeah. Good afternoon, everybody, and thanks for taking time out for this session. I know we are standing between you and lunch, so we'll try to do justice in the time that we have been given. So the topic is being transparent about our machine learning predictions. Machine learning is the buzzword, not only in the actuarial world, but elsewhere as well. Actuarial profession, as the trend we see going forward, it is going through a metamorphosis. Just imagine a scenario that we are doing today, experience studies. We get a lot of data from different sources, sometimes consistent, sometimes structured, sometimes unstructured. We play with the data files, make it consistent, do some experience studies on that, come out with results, try to analyze things, and feed them into our reserving models or pricing models or cash flow testing or other financial predictions that we do. And this entire exercise might involve playing with some maybe 200 spreadsheets involving a dozen individuals. And the work may involve maybe a week's time, maybe a month, sometimes even a complete quarter. But we are doing that, and it is essential. Now, the way things are being projected, maybe 5 years, maybe 10 years, imagine a scenario, day 0, an actuary receives a very clean data from the data lake that the organization has built. He compiles and clicks a button and goes off for a weekend. By the time he comes back on Monday morning, all the results segregated separately in a clean fashion for reserving, for pricing, and all the dashboards are prepared, and not only prepared, but mailed to the internal stakeholders. Sounds fascinating and interesting. And it is going to happen because actuaries are an expensive resource, and it will be justified in doing all these because machines are becoming more predictive, and it will be a desire to get a high quality return on human capital, that is actuaries. However, when stakeholders ask us questions, okay, you have set the investment return as 4.25% or something, we have n number of files, we have the entire process before us, and explain that how we have arrived at this rate of return or this lapse rate or propensity to buy something or lapse a policy. When this entire exercise is completed by an algorithm and we go out with such kind of predictions, even the regulator or the stakeholders say, yeah, you have a very clean hairstyle, but how clean are your assumptions? Can you explain? And then there's a big question mark. And this is not restricted to actuarial, and this is something in the forward, in the future that we see it. Things are happening in other worlds, other side as well. Okay, so in a recent example, in the science, in the medical science, around 700,000 patients' data was analyzed for over 2 decades, and their data was used to build a predictive model which would help us predict the onset of diseases maybe 5 years or 10 years from now in a patient. And some of the diseases like liver cancer or maybe schizophrenia, the kind of accuracy that this model gave out, it was really fascinating. And of course, all the programmers and the medical researchers who were involved, they were happy to see, but they just could not relate how this outcome has come, because the algorithms, it used thousands and maybe millions of steps to arrive, and the interaction between various variables which were studied, and it was really difficult to go back and track how this result they came out. And regulators, they want the explanation. For example, FDA in the US, they came out with 21st Century Cures Act, which asks about the steps that were involved in coming out at this kind of prediction. So long story short, we need to explain the models because stakeholders want it, regulators, they mandate it, and at the same time, our models need to be trustworthy so that people can use it and it can be widespread use. Similar is a GDPR, which came into being last year. It also gives citizens a right to explanation on the kind of data processing that their data, personal data, undergoes. So we need to explain the black box that this entire algorithm or machine learning prediction. So being coming from aviation, I spent almost 14, 15 years there. Black box is flight data recorder, which tells you step by step how the aircraft was operated in given conditions. So it was, the name is black box, but actually tells you everything. However, in this scenario, the black box is actual black box, and we just are not able to explain how things are happening inside it. So our session on this is about explainability of our models, and we have used publicly available data on a case study, and I'll hand over to Abhijit, who is a data scientist, and he will take it further.
Good afternoon, ladies and gentlemen. And thank you, Hemant, for setting up the context. What I would like to start with is, since we are hearing about AI, ML, all these terms from a couple of days, and every day there is some news item that talks about all these fascinating technologies, I just wanted to give, just from the usage perspective, how we should use these terms rightly. And I really liked this four-circle analogy. So if you just see, artificial intelligence has a very broad scope. It contains a lot of things that needs to be addressed, like cognition, problem solving, learning, language understanding, right? So all these are sub-areas in the AI space. And machine learning is a subfield in AI which tries to address the problem of achieving artificial intelligence through learning. And then there are several learning paradigms like inductive learning, abductive learning, and under that there are several algorithms. So if you just read inside out or outside in, you will easily identify where you are in this entire spectrum and just cater to that. Now coming back to the explainability part, so traditionally the linear methods are pretty straightforward to interpret in terms of the coefficients, that the kind of signs they have, and we can easily make out like a percent change in a particular variable, how it impacts my outcome, right? But with the advanced methods that falls under ML or AI, it becomes a little bit difficult to explain all those black boxes. So we then started visiting, rather looking at a lot of literature papers, how people are trying to address this aspect. And one of the perspective that was put forth was, can I view any explanation of a model's prediction as a model itself? So we called it as an explanation model. And in that, we came across a very interesting algorithm, which is based on game theory concepts. So game theory falls under optimization area, and to be precise, we are talking about the Shapley value estimation technique, which is like a cooperative game theory concept. So the idea is very simple. All you have to imagine is the prediction task as a game, and each predictor is playing some role in the payout that you will receive at the end of the game. So the payout here is the prediction that I'm really trying to make. So let's say I'm trying to solve the fraud detection problem, and the probability that a certain claim is a fraudulent claim, so that probability is the payout of that game, and how each of the attribute or the variable is playing a role in the probability that I'm getting at the end of the model building exercise, right? So I just put down this formula of calculating the Shapley value, but in the interest of time, I'll just like to switch to the next slide, which gives you the intuitive explanation of the Shapley value concept. So let's say you have three variables that you are dealing with, and you can just imagine an empty room, right? A kind of black box. And the expectation is that once each of these variable enters a room, you will get some payout. Now imagine there is no variable in your model where you will look at. You will look at your historical data, right? And you will just say, okay, historically there was 11% fraud in the claims that I received. So if I don't use any of the predictor or the claim level characteristics in my model, I will say on an average, I expect 11% fraud. Now, variable enters in a room, the payout changes. The probability of a claim being fraudulent changes. Then another variable enters in a room. So now they form a coalition, right? And we can just try all possible combinations for all the variables and see its impact on the payout that I'm receiving, whether it is pulling it on the positive side, whether it is pulling it down, that is the negative side. So what Shapley value tries to do is basically it calculates the average change in the prediction that the coalition already in the room receives when the feature value joins that particular team or the coalition. So one can think of a scenario where you are dealing with thousands of attributes, thousands of variables in the model. So it becomes computationally very expensive to, try all possible combinations in the coalition. So there are some approximation algorithms that people have devised, and one of the interesting algorithms that we use in our work is based on Monte Carlo sampling algorithm, and it's available publicly. It's available in the research literature. So I'll not spend much time in each of the steps, and I'll quickly move on to the case study that we really want to cover in little bit details. So we resorted to the open source data that is available on a site called UCI Machine Learning Repository, and it falls under the banking domain. So the Portuguese banking institution, they released this data, which comes from the direct marketing campaigns that they ran for their term deposit product. And interestingly, this data was posed as an analytics challenge on a Kaggle forum as well by Singapore Actuarial Society. So it's already in your world, the actuarial world. So the problem that they really want to solve is to calculate the propensity of a particular client who can subscribe to a term deposit once this direct marketing campaign is over. So for processing the data, we primarily used SAS and R. The kind of variables that are available in our data, we just clustered in 3 categories. So the client characteristics, their demographics like age, job type, what type of credit history they have in terms of the loans and all. Then there are a few details related to the campaign that this institution has run, what was the contact type, the communication type, then when the last contact was made. And then there are a few macroeconomic factors that also play a role in taking these kind of decisions. So consumer price index, then Euribor, which is a kind of interest rate in that market. So as a part of standard modeling exercise, we cleaned the raw data. We did some of the transformations. We did missing value imputations for certain variables. Then we randomly split the data as training and validation splits into 80% and 20% respectively. And then we used one of the famous technique in the machine learning space, that is random forest classifier. And as you can see from the snapshot that I collected from the R environment, the model looks pretty stable across both the steps in terms of the accuracies that we could gather. So I'll say it's a good generalized model. Now comes the explainability part. And while exploring the literature, we came across this interesting plot. We call it as partial dependence plot. And I just created this plot for one variable, but you can use or rather create for all the variables that you really want to understand in a little better way. So essentially what this plot tries to do is it assumes basically the independence of each of the feature, which is a standard algorithmic assumption that we make. And for, let's say, I take the example of age here. So I have one client of certain age. And then what I'll do for all possible age values that I have in my historical data, I will change for that customer, rather than impute his age by all those possible values and see the impact on my output. And this I repeat for all the clients or all the customers' data that I have, and then average out all those predictions. So how I can interpret this plot, basically, so if you just see, there is a peak between 25 to up to approximately 40 years, which is kind of where customers are at their careers peak as well, and they really want to make some investments and gain something out of that. But as the age is towards like beyond 45 or 50, you can see the probability that they will buy certain term deposit kind of products starts falling, which makes a lot of sense in this case. Here is one example output for one single customer. And good thing about this approach is you can get the breakdowns for individual level customer data. And on my left hand side, if you see, the circled area shows you the actual value that we get out of the model, that the probability that this customer will buy a term deposit product is 0.44. And then there is the average prediction, which is historical data, which is roughly 0.25. So Shapley value actually tells you the breakdown in terms of all these predictor, how each of the predictor has contributed in gaining that on the probability dimension, that is roughly 0.19 in this case. So if you just see, the contact type is playing a major role for this particular customer. Then there is a job category. Then there are variables like Euribor, which is the interest rate during that time. So all these factors are playing positive role, but then there are certain factors which are pulling it down. So basically age factor, if he is like a senior citizen, there is a negative impact that he will buy a term deposit product. So you will just get all these breakdowns for this particular method, and you can pretty easily explain to the end user why this probability looks like this compared to the average prediction that is available to me historically. So just we want to understand these predictors or the variables in a little better way. We use the same customer profile and just imputed the job type. So if you see, the job type earlier was admin, but when we change it to the housemaid, the probability suddenly dropped by almost 14%. And again, we get the explanation. So the factors which were contributing earlier positively, they still contribute positively. There is no interaction kind of effect that is being played here. But if you just see, the major contributor which has pulled down the probability by 14% is the job type. So just changing from admin to housemaid is pulling down that probability, and we can very easily explain it, and it can correlate with our own way of thinking. This is one more client that we pulled up from the other spectrum, other end, the person who is unlikely to buy a term deposit product, so very less probability, almost 6%. So the major factor that is playing a role here is basically the contact type, which is telephone. So for a person of age like 38 and having a university degree, a decent job, which is admin type, this particular direct marketing strategy is not working. And we have observed even at the aggregate level, certain age groups are showing tendency towards certain contact types or the communication types. So it becomes really explainable in that sense. So just to conclude, we also came across several other methods we thought like we will just mention. We have just started exploring this field from the explainability perspective. So there are methods like LIME, which is local interpretable model agnostic explanations. It's a kind of surrogate model. Then there are a couple of methods which are very specific to deep learning paradigm, which is very famous these days, like deep lift and layer-wise relevance propagation. And then there is example-based approach. So they talk about counterfactuals or adversarial examples. So basically, you are imputing your existing data, perturbing it in a systematic way to test the impact of particular variable on the outcome. Over to Hemant.
Yeah. So long story short, we are embarking on a journey involving a big percentage of our data analytics and predictive analytics in our day-to-day work. And regulators and stakeholders, they have started raising questions about the outcomes and the explanation. And regulations will definitely come towards that direction. And before we advance too much into this direction, without being able to explain the models, I think it will not be a wise step. So scientific community, data analytics community, they have started thinking in this direction. So before we move too far, I think we should pause for a moment and look at our models, whether we are able to explain the results. And this is where this session was directed at. Thanks for your time. Thank you.
I'm going for the standing ovation, so I will take not more than 8 minutes. Okay? So, before I start, let me see how many people are awake. How many people have watched the Bollywood movie, Chak De India? Yeah, everybody. Yeah? Apart from the foreign friends. You have been there. Wow. So in that movie, there is a dialogue where the hero says that I'm trying to convert this silver medal into a gold medal by rubbing. Yeah. So machine learning and AI is the technology that would potentially help us convert what is currently unstructured data into gold. When we're able to create a framework for that, that is the premise from which I'm coming. And the second thing that I want to state here as to what is my background to make this presentation is that I believe that machine learning and AI is the technology as powerful as the atomic energy. Atomic energy was invented in 20th century, while machine learning is applied in 21st century. What went wrong with atomic energy is that the first application of atomic energy was for nuclear bomb. While currently we are seeing machine learning and AI being applied for manipulating people's behavior into buying certain products or voting for certain people. Because there is no framework, there is no philosophical framework that has been changed in the society because of invention of a radical technology like machine learning and AI. This is a professional conference, so I'm not going to try to give up a societal framework as to how AI and machine learning should be applied. I'm trying to create a framework here which would be applicable for an insurance company, and my background is in investment, although I have learned machine learning now for the last 7 years. So credit risk is one risk that insurance companies take, and that risk is basically lopsided risk. If everything goes well, you will get the coupon, that's it. But if something goes wrong, you lose most of your principal. So managing that is very important. Having said that, let me now move forward. Yeah. So the paradigms that are currently being used, there are multiple paradigms. There are historical paradigms for corporate. The ratio analysis that is in the morning, in the first lecture, we talked about LCD and PD framework, which is now being applied in India. Then there is a market-based analysis, which is called credit spreads. You look at credit spreads and try to analyze the credit risk. And there is KMV kind of models, which are option-based credit risk models in existence. None of them use machine learning and AI. And then there is a retail model, something like what was discussed in the previous presentation, where in the previous presentation we discussed about what FD the person will buy or not. Here the model is basically rule-based approval of loan. If your salary is so much, your existing loan is so much, then additional loan you can get so much. So these are the current paradigms without using machine learning and AI. What I'm trying to show is that how one can create a new paradigm, how you can use new silver coins to grind against this grindstone of machine learning to convert it into gold. Yeah. So what are the real factors that affect credit risk? The real factors, if you go logically, are the business decisions that the business takes, the competitive pressures, the regulatory environment, international trade, how things move. Let us say now what is happening between India and US, or China and US, the trade, the climate change, social stability. We talked about people getting older, how that affects different companies. Great. Input prices, exchange rates, and finally, how I am willing to honor my commitments. This is the most important thing in India. Yeah. Now, if I go back, none of these things are explicitly modeled in the current credit risk paradigm. Okay? Yeah. If you look at this, ratio analysis, how can I relate ratio analysis to a business decision or to a regulatory environment? No, I can only link it indirectly. Currently, there is no way I can link this together. Having said that, now let me move ahead. Now, what are the shortcomings of all the current paradigms? Is that last period's output becomes this period's input. I will look at last period's ratio analysis to see how I take decisions now. I will look at last period's probability of default to see what decision I do take now. There is no underlying explicit relationship between the actual cause of the risk and the outcome of the risk. I believe something similar happens in mortality predictions that we use, but I'm not an actuary, so I don't want to comment on that. Mainly because why this happens is that the underlying credit risk data is unstructured. You get the information about decisions made by companies in news reports. You get regulatory changes by way of circulars. You get information about something going wrong with the company by way of pictures. Let's say there's a flood happening in the company's in the factory or something. So everything is unstructured right now. Since we didn't know how to handle unstructured, it was kept aside. What we knew how to handle, we developed a model on that structured data, and we used it. That is what is happening right now. But that can change. Yeah. Let me give the framework of what is happening in the world as a revolution by looking at image analysis. So image, in old days, we used to do painting by hand. Even now people do painting by hand. But that was the only way one can make image maybe 200 years ago. Then came chemical photography, photo films, and now we have digital images. That is the progression that has happened. Now, what is the difference in this? Paintings were not automated. Photo film is automated. Even digital image is automated. Is it digital? Only the last one is digital. Replication cost of painting is very high, while replication cost of digital images is very low. Can you analyze single image using some technology? In paintings, no. It has to be some person, expert coming and say this painting is this painting or that painting. While in digital images, machines can do that analysis. Can I do analysis of all the images at a macro level? I can do only in digital. And now that framework is becoming reality. Now that we need to take advantage of this new technology available to create a new paradigm for analysis of credit risk. So if I now put these two things together, what is the underlying credit process and what is the technology change happening? Now I can create new structure, new methodology, which can be used to do credit analysis. So create structures from unstructured data. So in our company, we are doing that for now last 5 years. Create models directly from reality. So we don't look at financial numbers. See, what is financial numbers? There is one reality which is existing there. Then some accountants come in and create an image of the reality in terms of financial numbers, and then you analyze the financial numbers, right? If you can directly now analyze the reality directly, you don't require financial numbers. Will this happen overnight? No, it will not happen overnight. It will take 20, 30, 40 years for this to happen. But somewhere, someone has to make a beginning. And I'm suggesting what beginnings can be made here. Yeah. So these are some of the products that my company has launched, Decimal Point. So in Coffee Pulse, what we do is we try to look at the price risk of coffee as a commodity by studying the news across the globe. And by studying the news, we don't have analysts studying that. We have machines reading the news in multiple languages, from English to Kannada to Spanish, Portuguese, understanding what is written there, and then bringing the news up front, saying that these are the news that are going to affect coffee prices. Credit Pulse is another product that we have launched, which looks at the 10K and 10Q, that is the quarterly filings of American companies, and looks at only the text. It doesn't look at financials. It doesn't look at P&L, doesn't look at balance sheet, doesn't look at cash flow. Just looks at text, what the company is saying about its last 3 months, what is talking about next 6 months, and tries to analyze the credit risk increasing or decreasing in that company. Image Pulse is something that we are working on, not yet launched. Image Pulse is we are trying to create a product for giving loans to poor people. Poor people don't have any documents to show their income. So by taking the photograph of people's houses, we are training the machine to estimate the income based on the photograph of the house of the person. So that is the work which is currently going on. And News Pulse is another product which many corporates are using, where the corporates can get news which will affect their business anywhere across the world automatically by using artificial intelligence. All these things can be used to create a new credit risk framework which will give you an indication of a regime change in a particular company's credit risk. Right now, we don't get any forewarning of regime change credit risk because all data is past data. In future or near future, we can get that kind of warning. So I believe I have kept up my promise of speaking up less than 8 minutes, and I believe if there are any questions, I can answer that afterwards. Thank you.
Well, this is complicated. Here we go. Good afternoon, everyone. My name's John Taylor. I'm President-elect of the Institute and Faculty of Actuaries. And I would like to, first of all, thank the Indian Institute for their kind invitation to speak here today, not least because as the member of the presidential team who will take over responsibility for the Indian region, I expect to be spending quite a bit of time here over the next couple of years and hopefully becoming part of one of the most vibrant communities of actuaries worldwide. I'm particularly pleased to be talking about data science because it's so fundamental to what we as actuaries do, both in terms of strengthening the core and expanding the horizons. And along with the Indian Institute, we're trying to do more to help our members engage with data science. And indeed, last week, I was privileged to open the first ever IFOA virtual conference, and it was on the subject of data science, where we had over 3,000 virtual delegates participating. And all of those video sessions are available on the IFOA website now to have a look at on demand. So I would encourage you, if you're interested in this topic, please have a look at some of the sessions there. Now, what I would like to focus on today is very much the public interest aspect of data science. It's one area that the actuarial profession can add a distinctive flavour. Now, I have to say I'm very much an optimist around data science and what it can mean for the actuarial profession. I think we have the skill set really to take advantage of this new environment. And if we take a little bit of a step back for a moment and look at the sort of fundamental skills that actuaries can bring here, I would kind of characterize, if I can get the clicker to work. No. There we go. So a lot of our heritage is in working with statistics and interpreting them. And indeed, we do that to try and deliver commercial value to our employers and our clients. And increasingly, data science is requiring us, as we heard earlier, to embrace some of the more kind of IT aspects of this. But that combination of skills is exactly what's needed to thrive in this new environment. And indeed, I think the technological change that's happening is exactly what actuaries need and want to deliver value. And as I speak to employers of actuaries in wider fields, and I ask them, why do they employ actuaries? The consistent theme I tend to get back is, yes, data scientists can be good at identifying correlations and seeing insights in data, but what separates actuaries is their ability to see the commercial significance, or the financial significance of those insights. And if that's our key value add, spotting the commercial value in data, what a tremendously transferable skill set to have in this new environment, one that's applicable not only in our core areas, but in every industry that's proliferating data. And that's where we can add a lot of value. Now, I don't want to talk particularly about those core skills. What I want to talk about is that public interest and ethical overlay, because in a world where many individuals and professions are trying to get involved in data science, I think our heritage in looking at the public interest is something that can truly set us apart and help us serve consumers and society in general. And that's the theme I want to develop over the next 5 minutes or so. Now, as a backdrop to this, what's happening with consumers and society at large is something described as the democratization of risk. So over the last decade or two, lawmakers and regulators have been saying to employers and insurers, if you're going to offer long-term risks, if you're going to offer long-term guarantees, what you have to do is make sure you're adequately How's that? Better? Yeah. So institutions are understandably walking away from those long-term guarantees and those risks that were once, those actuarial risks of longevity, of insurance, of investment are passing from institutions to individuals. And I've used the Indian National Pension System as a manifestation of that. Those individuals who are investing in the National Pension System have to make decisions around where to invest, how long to invest for, and indeed how much to invest. So individuals have those risks. They may not be aware of them, but they have decisions that they need to make. And it's really data science and insurtech that's providing the opportunity for us to take the actuarial skills, modelling techniques that we've developed to support institutions and try and come up with new delivery mechanisms to support consumers. And indeed, I think there's a fantastic quote that summarises this very well from a book that I would commend to all of you called The Future of the Professions. It's not about the actuarial profession, it's about all professions, but I think they capture this challenge and opportunity really neatly in the following quote. So insight and guidance that could once could only be delivered directly by professionals can be made available through, for example, an online service where under the bonnet complex models are being used and they may not be apparent to the lay users of a system. And those of you who heard me talk here last year would know that I'm involved in robo-advice, that's delivering online decision support to consumers in exactly this vein. I've heard other examples throughout this conference where we're taking institutional investment methodology and trying to deliver it in an accessible manner to consumers. And I think in many ways that's one of the key challenges and opportunities for the profession over the next decade or two, trying to take institutional techniques and deliver them to individual consumers. And I think there's also a business model challenge associated with this. It's one thing to deliver advice to institutions and receive a check for a day rate or an hourly rate. but we need to find a different way of monetizing those skills when we deliver the benefit to consumers. Now, with that opportunity does come a responsibility to deliver this in a manner that is sustainable for the long run. And I think this is where the professional ethics very much come into play. So if we think about the world of insurance for a minute, for a long time, the profession has delivered insurance through the principle of pooling. And, you know, we use, of course, medical underwriting, we use to try and dice the kind of insurance pool into smaller segments. But data analytics and data science is just taking this to a completely different level. You know, already data from wearables is being embraced in life insurance underwriting and, of course, health insurance. And we've got biotech improvements that are going to transform this in the imminent future. So the cost of sequencing the human genome is now commercially available at something like $500 and plummeting dramatically. So very soon, you know, individuals will have access to genome data in a way that has simply not been feasible previously. And of course, that allows us to manage and understand risks at the individual level. And that can be quite helpful in delivering bespoke products to individuals. It can also help individuals understand the implications of not managing their health effectively. So if the number of steps is reducing and the cost of insurance is increasing, you know, there's an obvious remedy for many individuals to take. But it does, of course, provoke the question of, you know, if there's data that you can't change, for example, something in your DNA, and insurance is no longer available to you at an economic price, then that potentially leads to financial exclusion. And this is where I think there's a role for professional bodies to start engaging with regulators and lawmakers to make sure that society as a whole is very well aware of these inevitable conclusions from the advent of data science. There's one other aspect of ethics that I would like to discuss, and that's very much related to machine learning and artificial intelligence that we heard about. So I've got this rather dramatic slide about the campaign to stop killer robots. So this is actually quite a well-respected lobbying group supported by Amnesty International, amongst others. And what they are effectively talking about is autonomous drones in the battlefield. Now, why am I talking about this, you might ask? Well, I'm not suggesting that this is the new wider field for actuaries, although why not? The reason it's here is really around our responsibility to make sure that the algorithms that we implement behave sensibly. Now, if done badly, now it's unlikely that any of our actuarial algorithms will prove fatal to individuals, but they can certainly damage consumers and indeed damage the brand of organisations that we work for. And if I give you a couple of examples from the United Kingdom, both in the realms of general insurance. So one example is where the annual renewal price for individuals is set with reference to their likelihood to shop around. And if the insurer deems that a certain individual is not likely to shop around, then the profit maximising algorithm says, let's increase the price significantly at the point of renewal. And you can do that year on year, compounding the increase to the extent that, you know, some individuals may be paying 3 or 4 times what they were paying previously. And of course, the individuals that are least likely to shop around are often, you know, elderly, vulnerable people who don't have access to shopping around. They're unable to do it themselves. And of course, that has resulted in quite significant brand damage for those insurers whose algorithms have implemented that profit maximising approach unabated. And so I think we have a very clear responsibility to make sure we know exactly how the algorithms are operating. Another example, a very recent one in the UK, is in motor insurance, where an algorithm was given access to trading data, sort of training data rather, that included policyholders' names. Now, you might think that's relatively innocuous, but what happened was where individuals were applying for motor insurance. If they had a fairly typical British name like John Taylor, they got a certain insurance premium. But the training data that the algorithm was exposed to understood that certain ethnic names carried higher risk. And so there were cases where individuals who had exactly the same risk profile, but one had an ethnic name and the other didn't, those with the ethnic names were getting a higher risk premium. Something that's not only illegal in the UK, but of course would also severely damage the brand of the insurers. So I think we need to be very careful when we're implementing algorithms and make sure that we are accountable for what they do and make sure they adhere to the overall public interest. So I think that's maybe not a unique perspective, but something, that public interest perspective is something that's very much embedded in the actuarial profession's mindset and something that I think can help us distinguish ourselves from others in this arena. So just want to recap that if we think of the traditional skill sets that actuaries can bring allied to a new understanding of the IT capability, I think this new world of data science and data proliferation holds untold opportunity for us to add a huge amount of value. And providing we do it with one eye on the public interest in terms of how we treat consumers and how we influence public policy, we can make sure that we are doing it in a sustainable way that delivers value for consumers and gives the profession a fantastic future. Thank you for listening.
Well, we made a noble effort to finish in time. We've gone just a couple of minutes over. So our couple of options are we could show our approval by providing a standing ovation as we leave for lunch. I would make one comment, though. I would like to make sure you appreciate the painting that we have had here today. We've ended with the cautionary tale that with great power comes great responsibility and the need to be humble about these tools. We've been given instruction, though, on how to demystify the black box so we can be more useful about how to see them. We've been given insight into how a third eye into looking at credit risk may reveal new opportunities for us to have a better handle on credit risk. And we've been encouraged to be courageous in stepping into this field. So I think a true masterpiece that does deserve an ovation for all of them, and thank you. So please come up if you have an individual question. I know these people would love to have it, but I would encourage you to enjoy the lunch that's outside.
That you will be receiving some SMSs after the session gets over. So please fill that feedback form because you will get a good prize after 5 o'clock. And I would request Ms. Shubha Nilkantan to hand over the gifts which are here. Please, ma'am.